Number 27. The graph of y equals 1/4 tangent of 3x has a vertical asymptote at x equals what? So this is kind of worded a little bit weirdly. It says it has a vertical asymptote at this value, but in fact, tangent graphs really have an endless number of asymptotes because it's a repeating function. And in fact, I can just show you what this looks like just for a little bit of, just so you can understand it a little bit better. So if I'm going to add a graph, 1/4, make sure that's in radians, 1/4 times the tangent of 3x. As you can see, this repeats over and over again, and you have tons and tons of asymptotes. And so the way this works is basically you're going to have an asymptote anytime that the tangent of x is undefined. So for example, at tangent of pi over 2, tangent of pi over 2 is undefined. So you'll have an asymptote right there at x equals pi over 2. Then you'll also have one at 3 pi over 2. And then again, pi later at 5 pi over 2. And you can get this from using trig ratios or from just looking at the graph of y equals tangent of x. But anyway, as you can see, there's an asymptote every pi radians. And so there's a difference then between this equation, y equals tangent of x, and y equals the tangent of 3x. And basically what this 3 does is it compresses everything. So if you imagine, let's say you had a function where at x equals 0, I'll make a table actually. Here's your x and y. So say you had x equals 0, 1, 2, and 3. Then right here, let's say when you plug in 0, you get 0, plug in 1, you get 2, plug in 2, you get 4, plug in 3, you get 6. So this is really just the equation y equals 2x. Well, let's say instead of plugging in x, you plugged in 3x. So this is f of x, and this right here would be f of 3x. So this is a little bit different. So where you would normally have 0, you'll still have 0, because 0 times 0, or 3 times 0 is still 0. But then where you would normally have 1, 1 times 3 is 3. So finding f of 3, that's 6. So here would be 1 and 6. And then in between, you have 1/3 and 2/3. So if you did 3 times 1/3, that would give you 1. And f of 1, you know, is 2. And then f of 2/3, 2/3 times 3, that's 2. And you know that f of 2 is 4. So as you can see, by putting in that coefficient inside of the function, inside of the tangent, it squishes it. That's a very technical term, by the way. It squishes it by that factor. So if you can imagine, instead of having these asymptotes that are pi apart, instead of being pi apart, they'll be pi over 3 apart. So the asymptotes will be pi over 3 apart. Well, then there's also the problem of finding out where is the first asymptote. So the way you can do this is we know that this is going to have an asymptote whenever this on the inside is equal to pi over 2, because tangent of pi over 2 is undefined. So we can just say 3x is equal to pi over 2, and so we know that our first asymptote is going to be at x equals pi over 6. I'm going to erase some of this so it doesn't get too confusing. So our first asymptote is going to be at pi over 6, and if they're all pi over 3 apart, or I'll rewrite that as 2 pi over 6 apart, just so these have the same denominators, we can find out when all our asymptotes are. So we have one at pi over 6, we'll have one at 3 pi over 6, we'll have one at 5 pi over 6, and basically you just find it's all the odd numbers times pi over 6. So 7 pi over 6, 9 pi over 6, and then eventually you'll get to our answer, which is 13 pi over 6. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with the solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.